Now let's look at the implementation of LRU, least recently used. So we have already seen not recently used, right? By using one bit of reference, we can only say one thing, whether a page has been referred in the last cycle or not. But then in order to implement this least recently used, what we can do is LRU. Instead of having just one bit, we can have a multiple bits. Let us say I have 10 bits, 1 2 3 4 5 6 7 8 9 10. Okay, now all the 10 bits will be made 0 initially. For every page we have these 10 bits, right? So how many? 1 2 3 4 5 6 9 10. Okay, so all the pages will have zeros initially. Now whenever a page has been referred in one clock, then the most significant bit will be made 1, right? And all the remaining bits will just be like this. And after every one clock, these bits will move right, which means that is called right shifting by 1. Then what happens is, in the next clock, all the bits are supposed to move right. Got it? So this is how it operates. Now at any point of time, let us say these 10 bits allocated for a page are showing these bits like this. At some point of time, let us say you have this 1 0 1 0 1 0 1 0 1 1, something like this. Then what it means is, the page has been referred in the last clock. Let us say it is clock number 1, or let us say I minus 1, and it has not been referred in I minus 2, it has been referred in I minus 3, it has not been referred in I minus 4, it has been referred like this. So now whenever a page has been referred recently, right, it will have in these 10 bits the most significant bit as 1. If it is not referred very recently, next to that if it is referred, then here it will have 1, right? Therefore by using this, any page which is having highest value in this is the most recently used, right? So by using this representation, we could have a history saved. It is all the entire history, right? It says what happened to the page in the past 10 cycles, whether it has been referred or it has not been referred at every particular cycle. So the more number of bits you use here, the more information you could save about the page. Now if a page has not been referred for a long time, then it will have lots of zeros here, and maybe at some point it will have 1. If it has all zeros, it means in the past all these cycles it has not been referred, right? Therefore any page which is having a least value in these bits is the least recently used. Least value in the sense, you convert this binary number into decimal number, and anyone which is having the least number is generally taken as the least referred. For example, if one page is having the value 1 and other page is having the value 10, if I convert all these bits, then what does it mean? One page is having all zeros, right, followed by 1, and the other page is having all zeros followed by 1 0 1 0, right? Then what does it mean? It means that this page has been recently referred, but this page has not been recently referred. Therefore the one which is having the least value will be now referred, it will be now replaced, right? So that is how LRU works. So LRU works, the main difference between least recently used and that not recently used is just that number of bits. So most of the implementations, they use 64 bits to represent this, okay, which means we are going to save the history about the page in the past 64 clock cycles. So whichever is having least value is actually least recently referred. Alright, that is how LRU is implemented. And now one more thing is LFU, least frequently used. So in order to implement this least frequently used algorithm, what we do is, with every page we associate a counter, okay, and then whenever any page reference occurs to that page, we are going to increment the counter, right? Then what happens, anyone which is having this least value in the counter is least frequently used, and any page which is having higher value in this counter is most frequently used. Then you can replace the least frequently used page for a new page. Got it? So that is how implementations vary. Okay, so these are various popular algorithms, and this is how the implementations work. Fine. So no question has been asked about the implementation till now, but then questions have been asked about how many page faults are there if I use this, if you use this. Such kind of questions have been asked. Okay, fine.